Bloom is a computer graphics effect used in video games, demos and high dynamic range rendering to reproduce an imaging artifact of real-world cameras. The effect produces fringes of light extending from the borders of bright areas in an image, contributing to the illusion of an extremely bright light overwhelming the camera or eye capturing the scene. Theory: the physical basis of bloom is that, in the real world, lenses can never focus perfectly. Even a perfect lens will convolve the incoming image with an airy disk. Under normal circumstances, these imperfections are not noticeable, but an intensely bright light source will cause the imperfections to become visible. As a result, the image of the bright light appears to bleed beyond its natural borders. The airy disk function falls off very quickly but has very wide tails. As long as the brightness of adjacent parts of the image are roughly in the same range, the effect of the blurring caused by the airy disk is not particularly noticeable. But in parts of the image where very bright parts are adjacent to relatively darker parts, the tails of the airy disk become visible, and can extend far beyond the extent of the bright part of the image. In HDR images, the effect can be reproduced by convolving the image with a windowed kernel of an airy disk, or by applying Gaussian blur, before converting the image to fixed-range pixels. The effect cannot be fully reproduced in non-HDR imaging systems, because the amount of bleed depends on how bright the bright part of the image is. As an example, when a picture is taken indoors, the brightness of outdoor objects seen through a window may be 70 or 80 times brighter than objects inside the room. If exposure levels are set for objects inside the room, the bright image of the windows will bleed past the window frames when convolved with the airy disk of the camera being used to produce the image. Practical implementation: current generation gaming systems are able to render 3D graphics using floating point frame buffers, in order to produce HDR images. To produce the bloom effect, the HDR images in the frame buffer are convolved with a convolution kernel in a post-processing step, before converting to RGB space. The convolution step usually requires the use of a large Gaussian kernel that is not practical for real-time graphics, causing the programmers to use approximation methods. Use in games: some of the earliest games to use the bloom effect include Outcast and Ico. Bloom was later popularized within the game development community in 2004, when an article on the technique was published by the authors of Tron 2.0. Bloom lighting has been used in many games, modifications and game engines such as Quake Live, Cube 2, Sauerbraten and the Spring game engine. The effect is popular in current generation games, and is used heavily in PC, Xbox 360 and PlayStation 3 games as well as Nintendo GameCube and Wii. Popular browser-based games such as the MMORPG RuneScape make use of the bloom effect as well. See also, afterimage, sometimes used to enhance the bloom effect. Chromatic aberration, tone mapping. References. External links: Real-Time Glow,